Okay, so our final bit to look at today is going to be the language of talking about structure and bonding, so we have to be very careful. So, as you can see, the word particle we can only use in physics. In chemistry, we need to be a bit more specific when we're talking about chemicals. So, when we are talking about an atom, we have to be talking about a particle that has an equal number of protons and electrons. When we're talking about an ion, we must be talking about a charged particle, one that has lost or gained electrons through ionic bonding. And when we talk about a molecule, we're talking about something that is made from two or more atoms that have bonded covalently. So you must use these terms, not the term particle. We have our two types of structure that we would have to talk about, our giant structures, which are ionic, metallic, and our few covalent ones that we've already talked about, like diamond, graphite, silicon dioxide, and our small molecular structures, which are our simple covalent molecules. And when we talk about our forces, we need to talk about the strong bonds in our giant structures, either strong ionic bonds or strong covalent bonds or strong metallic bonds that require a lot of energy for us to break them apart. And then we have our weak intermolecular forces, which are only present in our small molecular structures because they have to be between intermolecular molecules, and these are the ones that require very little energy for us to break them apart. So if we remember rightly, our giant ionic has ions with strong ionic bonds. Our giant covalent has atoms with strong covalent bonds. Our giant metallic has our ions with its sea of delocalized electrons and a strong metallic bond. And then our small molecular has a strong covalent bond in the molecule holding the atoms together, but we're never going to break those because the weak intermolecular force, the force between the molecules, is going to be broken first. So let's have a look at what that means in terms of some questions so we could give them some answers. So if we were looking at why magnesium oxide has a high melting point, our first thing we have to identify is that magnesium oxide is ionic. So we would recognize that this is an ionic structure, which means we're going to be talking about ions. And because it's a high melting point, it's ionic. It's a giant structure. So why does it have a high melting point? We're going to have strong ionic bonds that require high energy to break. So we would have that high melting point. Next question. If we had a look at ammonia over here, so ammonia, we would be looking at why it has a low melting point. Ammonia is going to be our simple covalent, so it's a small molecule. It's given away because it's a low melting point, so we would talk about weak intermolecular forces because it is a molecule, and low energy to break, so it would have a low melting point. So graphite, interesting way to spell break. Graphite has a high melting point but is soft. Again, we need to identify what we know about graphite. So graphite is a giant covalent, but it's our exception. So remember, graphite is the one that's a little bit strange. The softness comes from layers and sliding, so the layers can slide over one another. The high melting point is going to be, because it is covalent, we would have strong covalent bonds, and again, high energy. So you begin to see there's a big pattern. You've just got to use the correct terms. So when we're talking about strong ionic bonds, we need to remember they're between ions, whereas strong covalent bonds are going to be between atoms each time. So we need to be very specific what we say. Aluminium, high melting point and conducts electricity. We're going to be talking about aluminium just as a metal, so you would have strong metallic bonds which require high energy, as you would expect to break them apart. Why does it conduct electricity? Well, we have that C of delocalized, and that's another of our key phrases, delocalized electrons. Now, we only use delocalized when we're talking about electrons in metals and in graphite. So they are the only two places we would talk about electrons being delocalized. Why is carbon dioxide a gas at room temperature? Again, the first thing to do is identify its simple covalent, and actually it's going to be the same answer as ammonia because they are both simple covalent. So we're talking about melting points and boiling points, so it would be exactly the same answer. The last one we could look at is a little bit more complex, explaining why salt water conducts electricity but pure water and the solid salt do not. They're expecting you to talk about all three chemicals. So they would be expecting you to talk about salt water, which is our dissolved ionic. So this would be a dissolved ionic compound. They would expect you to be able to talk about water here, which is our simple covalent. And they're expecting you to talk about our solid ionic, our solid salt, which would be just our ionic. So they're expecting you to recognize the three different structures that are in there and then talk about why that gives them their behaviors. So our salt water conducts electricity. Why does it do that? Well, it's because the ions can move. So remember, with our ionic, we're only talking about ions. The ions can move and they can carry the current. They can carry the current or the charge, depending on which word you prefer to use. So why do our other two not? Well, water, our simple covalent, will not conduct electricity because molecules, remember that's our key word for simple covalent, are not charged. So they can't carry the charge. They can't carry the current because there is no positive or minus to carry it. Then our ionic, why does our solid salt not carry the current? Why is it not electricity? Well, there's ions in there. We know there are charged particles, but in this case, our ions do not move. So it's all about using the correct keywords in the correct places. So if you had written atoms can move in the salt water, you'd get no marks because there are no atoms in a dissolved ionic solid. We would be talking about ions specifically. So always stop and take the time to go, okay, what kind of chemical is this? Carbon dioxide is a simple covalent. What key word do I need to use for that? It's a molecule. I need to be talking about it. These are worth a lot of marks, and you've got to hit the language correctly.